Well, good afternoon. I'm glad that we've got you here today. My name is Carolyn Dindorf. I'm a limnologist and also the vice president at Fortin Consulting. We're just a small environmental consulting firm in the Twin Cities and do a lot of work with water resources, especially as it involves education. And one of the things that we've been working on quite a bit in the last few years is road salt and its impacts on our waters, and what can we do about it? So that's what we're going to talk about today. Winter maintenance, we've discovered, is a problem for our lakes and streams and in our groundwater as well, and it's basically the chlorides and also the sands that cause problems in our waters. I think we probably all know that pretty much everything we do on the land can affect water quality, whether it's a lake, stream, or groundwater or wetland. You know, the water is going to run downhill and with it pick up pollutants and carry them to whatever that nearest water resource is. So what about road salt? How does that affect our streams? Now hopefully, or our waters, hopefully we're not going to see something like this in the future for our streams. This one happens to be in Nebraska. I think Connie Fortin, my business partner and owner of Fortin Consulting, was going to Nebraska to do a talk on this and came across this sign and of course had to stop and get a picture. Specifically for chlorides, we do have some standards that are set. It was set by the Environmental Protection Agency. In this case, the same standard was adopted by the Minnesota Pollution Control Agency. And it's a chronic standard, which means sort of long-term exposure to a chemical, although we're talking a few days as opposed to instantaneous type exposure that can impact aquatic life. So this standard is an aquatic life standard. It's not like a drinking water standard, that sort of thing. So it's based on the amount of the pollutant that will impact aquatic life.
So you're saying at this level?
At the level of 230, they think this is sort of like the trigger point for when if it exceeds this, then it's considered impaired. These levels hopefully are set so that there's, you know, a margin of safety as well. But, you know, of course we don't test every species. We can only test a certain number of it. Often you'll test like the little Daphnia that will reproduce quickly so you can see it, or some fish. But we're not testing every species. So there may be some species that are more sensitive that we don't know about. I forgot to mention that's equivalent to about, the 230 milligrams per liter is equivalent to about roughly a teaspoon of salt in a 5-gallon bucket of water. Just to give you an idea what that might be. We know that bluegills can die at concentrations that are about 100 times greater than that, or excuse me, 10 times greater than that 230 milligrams per liter. So, you know, ideally there is a margin of safety, but we don't want to try to exceed that. And we are seeing some concentrations that are greater than that in some of our waters too. Shingle Creek in the metro area, kind of the north metro area, was the first one in Minnesota that was listed as impaired for chlorides. Now, just as a little background, we don't often test for chlorides in our water on a regular basis anyway. I think it's changing a bit now as we're seeing some impairments. But many streams aren't tested or weren't tested for a long time, so I think we may see more as we do more testing or start to test them at the time, you know, the middle of the winter and spring when we start getting the melt, when we're more likely to see them to be impaired. Shingle Creek, they did a TMDL study, the total maximum daily load, which is once it becomes impaired, they have to do these studies to kind of determine where is it all, what's the problem coming from? And in this case, they did determine that it's road salt is their main source. And determined that they needed to do a 71% reduction in the amount of chloride that, you know, has entered the stream in order to get it below that action level of 230 milligrams per liter. So do we think that's going to be easy to drop it by 71%? No, it definitely is not. That's going to be a big task. And since that time, a whole lot more streams have gone on the list. This is the 2008 list. Now we now have 7 streams that are listed. Now most of these you'll find are in developed areas. In the metro area, a couple that aren't. And those sources might be something different. It might be agriculture or some other sources. So we're definitely seeing it a problem. Now, it seems kind of funny to be talking about winter maintenance and road salt when it's 70-some degrees outside, but some of these things we can plan for now and so that we can hopefully improve our practices for the next year. Not only are our streams becoming impaired, we're also seeing our groundwater as a problem and getting high concentrations of chloride. And a study that was done by the USGS, United States Geological Survey, from 93 to 98 found some of the greatest concentrations of chloride in our metro groundwater, the wells that were tested, in all the areas that they studied, 29 different areas. A recent study by St. Anthony Falls Laboratory at the U of M also found some problems with groundwater. And there is actually a secondary drinking water limit that's set, so that's a little bit higher, 250 milligrams per liter, because obviously aquatic life's probably not so much of an issue in a well. But there is a drinking water standard, and these large dots here is where it was found to exceed that. So kind of all around the metro, we have some exceedances in these different wells, and these are normally the shallower wells, not the deep wells. So we're seeing definitely a problem. And what's interesting, back up for a second, and these two, in our streams, we're seeing high concentrations of chloride in the middle of the summer. Why do you think that might be? What happens is the base flow for our streams is often from the groundwater. So in areas where we've got high concentrations in our groundwater, we're seeing these summer peaks. Shingle Creek is one of them where we're seeing some high concentrations in our streams right in the middle of the summer, because that groundwater that's high in chloride is feeding that stream. And if you don't have a lot of dilution from rain, if it's in a low water period, you may see some exceedances of that 230 milligrams per liter right in the middle of the summer.